With question 10, it's a calculation question, and I want to point out it does say answer to 3 significant figures, even though if you were really doing this you'd probably answer only to 2, but I'll show you that when we go through this. So we're looking at Ka here, and it's a solution of xh. So the first thing you should do is come up with an equation for xh that is reflective of Ka. Now what we learned from the 2 previous questions, questions 8 and 9, is that to get the other product, what you'll do is you'll take h plus away from it. So x minus plus h plus is what that would look like. You take off the h and the sign goes down by 1. The charge goes down by 1. Okay, so we've got initial molar. We have equilibrium molar here. The xh, that's 0.49. And this will be 0 and this will be 0. And then after equilibrium, some of it will dissociate, so become 0.49 minus z, and that's going to be z, and that's going to be z there as well. Now we are given the pH, and the pH here is going to be 1.4. Now the pH is a direct line here to the concentration of H+. So what we know is that if the pH is 1.4, then we can get the concentration of H+ by taking 10 to the negative pH, which in this case is 10 to the negative 1.4. And that is going to be 0.040, which also happens to equal Z as well. So the concentration of H+ is going to be Z. So now we can go ahead and do our Ka equation. So Ka is going to equal x minus H plus over xh. We can substitute in our equilibrium concentrations, and then we can substitute in our values. Now the 0.49 minus z is going to be 0.45, which is correct for significant figures because that has 2 decimal places. We take off 0.040, becomes 0.45. Our final answer is going to be 0.0356, but if you were really answering this on a test, you would write 0.036. Here, I'm asking you to do it to 3 significant figures so that things work out for me when it grades.